Thank you, Brian. So thank you very much, everybody, for waking up so early and coming to this session. I know it's very difficult. Myself, I had some problems this morning to wake up because, you know, it's FOSDEM, so Saturday night, generally, you do stuff interesting with friends, and you remember that you were called by Brian to say, hey, you need to give a talk tomorrow morning, or I propose my name. So sorry if it's not exactly the same topic. By the way, we can talk about the original topic because I have planned for that, and it's a topic which is also interesting. The relevance of Linux distribution at the era of Docker containers. It's something that we can address, hopefully. I will cover it a bit, but if you have questions on those topics, if you have concerns, then raise your hands, and we will try to do our best to answer those points. So let's start. So my name is Bruno Kornek. I'm working for a hardware manufacturer. I won't give the name here because they didn't want to support my travel this time. So I will use my association name to present the topic here. I've been doing Linux and stuff for the last 25 years. And I'm part of different upstream and downstream projects. For this talk, I'm particularly concerned because I'm a Mageia packager, and I had some development to do to be able to package more easily at the container era. Okay, so let's start with a few reminders so that everybody is on the same page. Containers are just, compared to hypervisors or bare metal environment, are really, really near to the bare metal infrastructure. The only stuff which is different from the bare metal infrastructure is that you have the engine which is managing the notion of containers here, and which is just a thin layer that you put on top of application. So you put an environment which is suitable to isolate the execution of your application if you want. So you have namespacing, you have C groups, which are set up, by the way, by default on your operating system. And here in a container context, that's the container engine which creates those environments of execution for the application before launching the application. So no specific overhead, because anyway the kernel is doing the job. That you use it on the bare metal or that you don't use it on a container environment, it's the same cost for launching the applications. Just the fact that you have an isolated environment is what is of interest to us in this context. So I will talk about Docker because I've started using Docker and adding Docker to the Mageia distribution 3 or 4 years ago, something like that, 3 years ago. And it applies to other type of containment engine, of course. Some stuff are typical to Docker, some other stuff are really generic to containers environment. So the idea is really to pack everything together to give you a new way of delivering application to your users. 40 years ago, you were using tar and a script in the tar file, and you were delivering your application to your customer like that, or to your users like that. After the Linux revolution, you had more clever way of doing that, which are called packages. And we are in the distribution dev room, so people building distributions are really keen to make packages to create a suitable environment for delivering application, taking care not only of the application itself and the right place where it should be delivered on the system, so having a standard, which is a Linux standard base, which gives you all the directories in which you need to install your software. The logs are in var logs, the application is under USR, you have etc for the configuration files, etc., etc. So this is standardized, this is taken care of by the distribution management system, and the distribution management system is also creating support for the dependencies, for the build dependencies of the software and for the installation dependencies of the software, which is a big advantage. So that's one of the elements why using distribution is still relevant compared to the Docker environment. So Docker came and said, okay, there is a new way of packaging application. You can have these apps in the box that we had in the previous slide, and everything inside that box, inside that context, can be shipped easily to another platform and run easily on another platform. So that's really the approach they had, is bundle everything. the approach is to say, okay, if you have one process you want to run, you will create one container. So if you have an application which is comprised of 7 different daemons running together, working together, then you would like to create 7 different containers, images, and 7 different containers to host them. It's working with layers, and I will detail that in the next slide. You have the notion of image and the notion of container, which is an instantiation of the image, which is read-write, in which you can work, whereas the image is read-only itself. You have additional features, so if you want to share your images, if you want to distribute your images, especially inside your environment or outside, you have the notion of registry. That's what the people from Docker run on the Docker Hub. So when you do a Docker search for an image, it's interacting with the registry. It's trying to find an image which has the name that you gave, and it gives you a list of dozens of different images corresponding to what you are looking for. You can do exactly the same internally, and you can have private registry as well to allow the sharing of images, which is like on distribution when you do repositories in your distribution and you manage packages inside the repository and you share the packages through repositories. They created the notion of Docker files. So this one is linked to Docker, which is the receipt to create the image. So you want to have instructions that helps you build an image on a regular basis. You can replay it. It's like the make file for building an application. It's a receipt to build the Docker image. Inside the image, everything is volatile. So when the container dies, you lose everything, sort of. It's stored on your disk in a layer, but you lose everything. So you want to have permanent information stored in volumes, which can be mounted from the host inside the container, or you can use network attached volumes if you need that. Inside the container, you are completely isolated from the world, so you need to specify which ports you want to make available to the outside world. So if you run one daemon inside an image, you want to expose a port of that network service to the outside so that it can communicate with the outside world. The goal is if you remember Java promise, it's write once, run everywhere. So it's pretty the same on the Docker container image. It's create once, run everywhere on a given OS. You cannot really mix and match between different OSs. The stuff I've not written here on the slide is that you have a standard describing images, which is the OCI, and it gives you the possibility to use the same image content with different implementation of container engines. So you can take a Docker image and run it with Rocket or CRU. When you want to orchestrate stuff, you go a bit upper in the stack. You have the notion of composition. You can create YAML files to give to your engine the information on how to launch the container, how to instantiate the container from the image. So which type of volumes you want to attach, which type of port you want to expose, which type of environment variables you have, which type of networks you have, all of that stuff that you can pass on the command line to the Docker command. You can also store it in a YAML file and give that YAML file to someone else, and you have the Docker Compose upper layer, which will create all the containers from that description based on the various image that you have. So HA layers is a swarm of Kubernetes that you can use. Everything is using a REST API, even the command line interface tool. So they always discuss with the Docker daemon on your system using the REST API. It's developed in Go, and the composition is redeveloped in Python, and it's licensed under the Apache v2.0. So I said in the previous slide there is a layered approach. This is how it's working. So everybody is using the same kernel on your host. There is no difference. There is no kernel inside the container image. So if you go inside a container image and you use a uname command to look at what is it, it's the kernel running below on your host system. It's not a kernel coming with the image. That does not mean anything, because it's just an isolation of processes. So You have the same kernel. It's launching different stacks, different application, but it could be a process that you run on your system, or it could be a process that you run in a container on your system. It's the same. Then on top of the kernel, once you have created that and you have your C groups and namespace available as feature of your kernel to be able to enable those type of working environments, you have the notion of image. So the image is a read-only part of the solution, and you can create as many layers as you need to reach a point where you are happy with your image. You can have something as simple as just a BusyBox binary. That could be your image. So you execute Docker, you create an instance based on that image, and you will be in an environment where you just have the BusyBox binary. And you have the 100-something commands that the BusyBox is providing to you in a very small footprint environment. That's one way to deal with it. You can use a very small distribution, like the Docker guy developed Alpine, which is a very small Linux distribution, to provide a strict minimum of environments that you need to have something which looks like a Linux environment, because BusyBox is really, really small. Or you can put a full distribution or normal distribution, the minimum set of that distribution. So for a Mageia distribution, it would be 200-something packages. For Fedora, the same. For Debian, maybe a bit less. Okay, so you have the possibility to really create a small layer which is the base of your distribution, and on top of your distribution you can install packages using your normal mechanism. So if you're on Debian, you do dpkg install, you do apt-get install. If you're on Fedora, you do dnf install. If you're on Mageia, you do urpmi. But that's the same approach. You just use native tools that you have on your distribution to build the context that you want to have. You can add scripts, you can add binaries, you can do pip install, you can do npm install, you can do whatever you want inside. And that's isolated. And once you are happy with the result of your build of the image and the running environment, then you can instantiate one version, which will be the container, in which you will have the right to write in it, modify stuff. And that's where we'll be running your application on top of it. Any question at that point? Is it obvious for everybody? Okay, good. So why do you want to use distribution packages with distribution and packages inside the distribution with containers and VM? And that probably was what the original speaker was intending to cover more. So first, why do you want to run containers? Because you already have a distribution. Well, what you want is not necessarily polluting your distribution with a ton of stuff that you want to test in a dedicated environment, especially when you do stuff like JavaScript, Node.js, type of stuff where very few distributions have packaged the whole stack that you would need to develop. That does not exist under an RPM format or a deb format, because it's really a moving target. You would need thousands of dependencies. When you do npm install of something, you get 10,000 of different modules installed through the network. That's a huge work for a distribution. And most of the distributions that just package the Node.js itself. So you can do npm install, and then the rest is not packaged because it's moving too fast. It's not possible to keep up with that. It's not the case of some other languages. You have a lot of Perl modules, a lot of Python modules, a lot of Java modules as well, which are available under a package format, so you can benefit from the work of the distribution people to have a coherent set of packages. But for moving target like Node.js, it's really something where you want to isolate it from your native distribution, because you don't want to install on a distribution something which is not packaged. Why? Because it creates, the manual installation compared to package installation is a direct way to create problems in your environment. Because you may have stuff in the standard place, and you may have at the same time the same stuff in a non-standard place. Under a USR local, for example, if you just do configure make install for a GNU software, it will by default arrive in USR local. And then you will have binaries in USR local bin and binaries in USR bin, and you don't know which version is which, and sometimes you don't point to the right configuration file because you have multiple instances. So really, if you want to have a serious execution environment and also build environment, you need to be very clear of what you do and identify clearly where you need to use non-package environments, such as Node.js, for example, compared to package environment. The advantage that containers bring, like VM, you're not polluting your running environment. You create an isolated place where you can do everything you want. At the end, it's just in that environment. And that's something you can send to someone else for test or whatever. So that's something you should be able to rebuild easily. So doing it with VMs, you should automate the creation of the VM, the operating system deployment in it, and the installation of your application in it, etc. It's easier with containers than with VMs, but that's the same approach. You want to be able to easily scratch and redo your running environment, execution environment if you have problems. And so it's easier with Dockerfile to do that and to address that and to rebuild on a regular basis your Docker images to be really up to date. Containers also bring something which is useful and that I'm using, and that's the goal of the talk, in fact. You can have on a single Linux distribution tons of other distributions available to make your test. So you can automate the portability of your application in different running environments in different distributions. You can package for different distributions your software so that it's installable natively for the people using packages from the distribution. So it's a really easy way to distribute for other distributions than the one you have, or for, I mean, I'm running the 6th version of Mageia, which is the last stable version. It has more than 1.5 years now, and we will issue 7 in a couple of months. But I don't want to run a non-stable distribution. I use my laptop to work, and I mean, working with a development distribution is prone to break my ability to work very often. So I prefer to isolate the test I do on the development distribution in a specific environment, such as a container, and that's the goal, compared to using natively the development environment and having the compiler broken for a couple of weeks because there are stuff that we need to put in place when we move from one version to another, etc. Another advantage of containers with regards to VMs is that it's very easy to share your home directory with the container. So you can attach, when you launch your instance of a container from the image, you can say to that, attach my home directory and put it in the home directory of the container environment so that I'm at home and I can use all the files that I need to work in my environment, which means, for example, that allows you to share, if you're on a RPM-based distribution, all the configuration files that are needed to build packages correctly. So RPM macros, RPM RC. You can also keep a look on your SSH keys. I have my SSH key in the build system of Mageia to be able to push packages and ask for the build system to recreate the packages I've tested locally. You can do the same with other distribution as well. What I do is really generic. It's not linked to Mageia itself. The only place where you really need a VM compared to a container to do that isolation is if you need a different kernel between what you're running and what you want to test. That's the only place where it's important. And for people like me who are doing packaging most of the time, I don't care. I can use a native kernel of my distribution to do the packaging. I'm packaging for 120 different distributions, the software I'm upstream for, without any problem due to the difference of kernel on the host and inside the packaging environment. So that's really feasible. So how do you deal with that concretely? So you have the Docker registry, or you have your own registry, or you have your own local images. You have a set of images that you can put on your environment. You create those images using a Docker file. I will show you the content of the Docker file just after. And every time you need to test something in a different environment than the one you're running, you instantiate a container for the distribution which is your target. And inside the container, you're building packages that then you can send to your distribution repository, either using Subversion or Git sources, depending on the distribution and the package management system of your distribution. Okay, so Maybe I should turn around and show you the real file instead of so the one on the slides for people who want to have a look after the presentation, but I should be able to show you something else here, which is a real one. Okay. Okay, so I have a way to capture some parameters as input, which is not really important. I have a configuration file that I can use to pass some variables and have default variables available in my environment here. So the version of the Mageia distribution target, temporary directories, a mirror that I can use to download the dependencies, a working directory, the architecture on which I'm working, because I can also build for different type of architectures. There is a very convenient project in QEMU which allows you, for example, to run on an x86 machine non-x86 binaries. As if you were in a virtualization environment, except that you are not virtualized. You are not in a VM. You are virtualizing the instruction set, but you are not in a VM. So I built just a Raspberry to make some tests with another architecture to see if it was working here. It seems to be very interesting. So I get my information, my UID, GID, because I want to map those inside the container. And then I generate a Docker file here. I start from what I call a Mageia official repository, which is in fact local to my system. So those are my local root images for the distribution. I can show you, if we have time, how it's built. The first thing I do is I update my distribution inside the image. When I build the image, I say I want the latest version of every package that I need. Then I can, okay, that's commented. Then you install all the dependencies that you need in your environment. So I update the repositories, and then I install all the dependency packages that have been updated since the last time. And I install in that environment, because I'm building packages, the set of packages I need to build packages. So there is a BM command which does the build through RPM build. Mageia is using Subversion for configuration files and stuff like that. We have the Mageia repo command, which is the interaction with the Mageia official repository and the launch of the interaction with the build system of Mageia. And some other useful tool like colordiff and sudo, because I want to be able in my build environment. So when you're building packages for a distribution, never build as root. That's if you take something out of this talk, is never build as root in standard, because when you're building a package, you don't know what you're launching. You're packaging a set of software which is coming from upstream, and those guys may do remove files, etc. And if you don't set up the right environment variable, you will remove files in a place where you don't expect to remove them. So never run as root, run as a single user. So that's why there is some magic here to create the user in the container image, associating the right UID, GID. This line is not useful anymore. And giving to that user the right to sudo in the container, and without any password, to be able to launch some commands as root when you need them, but not when you don't need them. And you do that on purpose. So all the build is done as a single user. But sometimes, if you want, for example, to install the build packages on your environment, then you will need root access to be able to write in the package database that you want to install the package. And then I create the home directory of that user. I say that I will be in a work there, which is my the place where I have my my Mageia environment. I run the container as a user, not as root, and I launch a bash command. And the rest is just some small part to detect if there is already a container. If I force, I can remove the previous image to rebuild an image. And then I just run. So this is a line which is creating the instantiation from the image. So here we are building the image with that receipt. once the image is built, you instantiate an environment. You say, I want to remove that environment at the end of the run. I want to map my, I want to be able to SSH correctly from my Docker container environment. So I need to make some stuff with the socket inside the environment and set up the SSH socket inside the environment to the same place where it is outside. So I can communicate using my SSH agent, which is already installed on my system. I just want to mount my home directory under my home directory inside the container. And I use the image, which is tagged like that, which is the name of what we are creating here in the receipt. So how does it work? So here I'm running on a Mageia 6, and I can create, of course, a Mageia 6 environment as well. So by default, so I didn't relaunch anything this morning, so I cannot, let me just, let me just restart the Docker daemon because I may change some stuff since yesterday. Let's try again. So I have a certain number of images. That's why it takes a bit of time. So there is a couple of images, and you see there are a lot of different distributions that I use to have different environments to be able to build different software correctly. So that's why it takes a bit of time. Is it better now? No, still not. No such host. So I may have lost my network, which is here. Where is my mouse? Here. So it should be here. I have the mouse here, which should be here. Yeah, I have no LAN. So can I use FOSDEM legacy here? Complete. The FOSDEM one. Okay. Okay, should be better. Should be better here. No such object. Ah, yeah, right. Dans l'autre sens, ce serait mieux. Okay. So the difference of -x 664, and I will run. Yeah, but the dash, yeah, it should be before. I'm not pointing to the right image. I miss the architecture here. Okay, so here, where am I? I am in a container which has been instantiated from the image which is here. You see at the prompt change. Of course, from that perspective here, it's still a Mageia 6 environment, but this one has 232 packages, whereas my native distribution has 3,000 packages. So I'm in a completely new, different environment. It's a fresh Mageia 6 environment, which has a minimum set of packages that you need to have to run the command which can install additional packages. So that's what you want to have. You have a bare minimum distribution on which you are able to use, if it's a Debian distribution, apt-get, if it's a Mageia URPMI, if it's a Fedora, DNF. That's just what you want to be able to do, because that plus the network configuration, correct? So that you can touch the repositories and download content from the repositories. So where you're here, so the stuff which is also not right is that I'm root in that environment. I should not be root. I should be a single user. Let me check. Yeah. So yeah, right. So this is the image. So this is the official image. This is the one I use as a base environment. So this is not the image I use to build my packages. I can do the same easily with another version. So if I use the Cauldron version here, I will be now in a different environment, which is the Mageia 7 version, which has a different set of packages. Only 219, so nice job for the guy working on that, because they reduced the size of the minimum distribution set from 232 to 219. So we have less packages when we want to create a small distribution with Mageia 7 release. And here, if you look, all the packages which are installed are MGA 7, whereas of course here, all the packages which are installed on my native system are MGA 6. So I have a working Mageia environment here, which is completely different. That I'm pointing to the development distribution. I have all the dependencies of the development distribution. I can really do what I want in that environment easily. Let me try to just fix that, because there is something wrong here. You should never make changes. Well, that's not really correct. In fact, that's not really correct. It's the day before the distribution, the presentation. Let me check, because yesterday I was building some stuff. So I have in my environment normally this one, for example. So if I go here into this one, yeah, which has the architecture. That was the missing part of my script. Script has not been updated for that. So now I have an image which is based on the previous image. So this is still a Cauldron version 7, but this time I have a bit more packages, because in my receipt, so if we look at the Docker file that we have, for example, where is the presentation? So if we look at the Docker file that we are using here in the presentation, which is the same, in addition to the standard distribution, which has 219 packages, I asked to add a couple of additional commands to be able to work. So for example, I should have the BM and the MGA repo command. So let's go back here. So here first, I'm a single user. I'm not root anymore. I change the environment in which I want to run. And I have access to the BM command. I have access to the MGA repo command, which were not there before. So, and I am placed in my directory where I have all the packages I'm following for Mageia that I can rebuild. So let's take, for example, something related to Docker. I have the Docker compose. I will do a remove of everything which is not relevant. So all the intermediate build stuff here, I just keep the sources and the spec file, which are the strict minimum I need to build packages. So for those not really familiar with that, maybe. So the spec file is again a receipt which gives to the RPM system instructions on how to build a package for the distribution I'm running. So it gives you some dependencies at build time that you need to satisfy to be able to build. And as Docker Compose is a Python script, it needs a certain number of Python modules to be able to build correctly. And then it will also indicate some installation dependencies. So if you install that package on the distribution, you will need to satisfy those dependencies around Python modules needed. And then you have the receipt to be able to build the software in your environment. So for the Mageia distribution, it's as simple as doing BM. And of course, it does not work. Not because it's a demo, but because it's on purpose. I missed all the dependencies. I show to you that there are build dependencies here, and I don't have those. If I do RPM, pipgrep, Python, I have a certain number of Python packages. Typically, what is needed to build Python packages, and the Python 3 and 2 versions as well itself, but very few other packages. Just setup tools is the only one I have. For example, I don't have, I think it needs the Docker package, the WebSocket client, etc. So all those packages are not available yet. So I can say to my system, okay, I need to be root because I want to install additional packages, and I want to install the packages which are mentioned in the spec file that I need to have. So it says, okay, I will default to using build requires. So which are the build requires that you need? Okay, you need a Python Docker package. Which one do you want? Say, okay, let's take the first one. And you have recommended packages or optional packages. So I say, okay, I don't want to pollute too much my system. So I would say, okay, do not install the recommended packages, just the one I really need to build. So the list of packages as dependencies which are needed in my environment are those. I will say install those stuff, and hopefully if there is a bit of network, I should be able to download them, which does not seem to be the case. Well, okay, so maybe the mirror is having an issue because I have the network here. Let me check. District coffee. Yeah. So I cannot touch the mirror myself either on the web browser. So I need another mirror. Let me try. So let's say, okay, this mirror is broken, does not want to deliver to me stuff. That's not a big issue. Well, that's a problem, but that's not a big issue. So I will go in my configuration file and I will change the mirror. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's do it the other way around. So I will change the mirror, the reference to the mirror here, inside the configuration file, to something which is better, which is the kernel.org mirror, which should be working fine here. Oh, there is two distrib. Okay, this time should be a bit better. So let's try again. Okay, so when you deal with a mirror which is up to date and available, you can download the dependencies to build your software. It installs them for you. So now you can build your package. And this time, as all the dependency requirements are satisfied, then you can build the package. And you have in your environment, again, all the directories that have been created. For example, you have the new package, which is available here, which has just been built in my environment, which is clean because it has been built using the Mageia Cauldron tools, Mageia Cauldron dependencies, creating an MGS7 version. So everything is completely safe from a build environment. And now I can just try to install it. And again, it's looking at dependencies at install time, and it's okay for installing that package. You will need those packages as dependencies, so just say yes. It will download some additional packages, and now you have the package which is here, and you can start testing it in your environment because it's working. So you have a strict minimum environment to be able to make tests of one package that you have built here, which is exactly what you want to do. And I'm not polluting the rest of my system. It's completely isolated, and I can do that as many times as I want with different distributions available. Okay. Any question? Yes.
So for distros that ship to multiple architectures,
yes.
you have here source RPMs and RPMs for x86, 64.
Yeah.
What do you do with that? You ship it to the distro, and then it has to be built for the other arches?
So generally, what happens by distro vendors is they have a build system. And on the build system, you have a machine with all the targets that you need to support or you want to support. So here I'm testing on my local system. I will check that everything is working. When I'm done, I can use the Mageia repo command to push my content to the build system. Pushing my content is just pushing the subversion set of files that are under control. So in my case here, where's my mouse again? Here, sorry. So here is on the build system the subversion tree that I mirrored locally. You can have a look at the different stuff that have been done from the system. So you see what happened to the life of the package during its development. You see when you have modified the compose file, when you have a massive build, for example, for Mageia 7, which happened, which change automatically a certain number of stuff. Okay, and when you are happy with what you have, so in your environment, what is important are the sources directory and the spec directory. So the spec directory contains the spec file that is mandatory to rebuild, and the sources directory contains the sources of the various versions I have had during time of that component, and a SHA-1 file checking for the checksum of the source file. So those are stuff that are in the Subversion repository on the repo in the Mageia build environment. And when I launch build for me the package, it will go to the build system, extract from Subversion the right files, do the BM command like me on all of the target systems that you need to support. So it will build for x86, i586, which is the 32-bit version, ARM7HL, because we are not like Debian, because I see you have a Debian t-shirt, so we are not as Debian maintaining as many architectures that you are maintaining, of course. And we have less packages as well as Debian, to be clear. Only 30,000 when Debian has 50,000 or something like that. So that's the way it's done. You have your target system on the build infrastructure that are used to build the final system. So you're building stuff, you're testing it. Of course, you may have a software which is working nice on x86 and not working on ARM, and you will not detect it through this process. You will detect it when your contributors say, hey, it's broken on my version, and you have a Bugzilla, you give the architecture on which it's not working, and people will make tests on that version if they have not done that before. That's the way it's done.
And Mageia's build system is also containerized or not?
No, it's a dedicated system which is, I think, using just root for due to. I mean, you don't change build system easily. That's one of the problem. So yeah, that's the way it's done. Any other question? How am I doing this time? Are we?
You're just about up. So one more question? Or
Okay. So if there is no other question, I'll leave you a bit of time to change room and get another fantastic presentation, hopefully. Thank you very much.